This is section 231. We're going to take a look at converting into graphing form. So we're going to convert a quadratic equation into graphing form, and we're going to examine how to find the vertex. And it's almost like a shortcut. So if you remember, if you rewind backwards, you probably learned how to complete the square. And the idea of completing the square says that if this was x times x, which makes that x squared, we have 4 x's. So here's 1, 2, 3, and 4. The question is, what do I need to put here to be able to complete that? And so it's 4 blocks, each worth 1. And so it would actually be 4 that I would have to add to quote unquote make that into a perfect square. Now the pattern that we do is we take whatever this b value is, 4, you want to divide that by 2 and you square it. And that's basically what you're going to add to be able to complete the square. So I would take that 4 over 2, it's 2 squared, that's 4. And so now that it's a perfect square, this statement here can factor. Right, if you do that whole Xbox thing, a times c is 4. Factors of 4 that add to 4 is 2 and 2. So you get x plus 2 and x plus 2, which is the same as x plus 2 squared. And so b over 2 squared allows us to complete the square. So first we're going to start off with how do we take a non-standard form function and turn it into standard form. So this right here, this is our general form function, and it's really common for us to get ax squared plus bx plus c. And sometimes we want to rewrite that into graphing form because it's, I'm assuming at least so far, we've looked at graphing form and you know it's not too bad. You know, you look at your h and your k and then you just move it and bam, you have your function. And so what we're going to do is we're going to take our value, our x squared plus 10x plus 23, and we're going to complete the square. And the process of completing the square is going to allow us to be able to turn it into graphing form. Now, real quick, if you noticed, I only used these values here. I didn't use any of this was technically blank. But coming back over here, I have that plus 23. That plus 23 is right here. I don't want that plus 23. So the first thing I'm going to do is I'm going to isolate it. And so the way that we isolate it is by putting parentheses around the parts that have an x. So now I'm ignoring this. Pretend like it's not there. We're just going to look at this, pretend like that's not there. And what we're going to do is we're going to complete the square. And so to complete the square, you take b over 2 and you're going to square it. And so in this case, that's 10. My b is 10, so I'm going to take 10 over 2, that's 5, squared. Now, the second thing is I can't just take that 25 and spontaneously add it out of nowhere. So we have to do this algebra trick where I'm going to both add it and subtract it. So we take that 25, we're going to add it and subtract it. And the reason I have to subtract it because 25 minus 25 is 0. So I'm technically just adding 0. But I want the 25, so now that I complete the square, but I can't just add 25 out of nowhere, so I have to include the minus 25. Now notice that plus 23, we're still just ignoring it. We're still leaving it alone. Now this part right here, that part will always factor. And so I can go through a times c. Factors of 25 that add to 10 are 5 and 5. So that's going to give me x plus 5 times x plus 5, which turns into x plus 5 squared. So this turned into x plus 5 squared. This minus 25 is the same. That plus 23 is the same. Now sometimes we might have a number in front. If we do, we have to distribute that to both of these values. Well, it's just a 1, so I'm technically just multiplying everything by 1. And so 1 times this is the same thing. 1 times negative 25 is the same thing. The negative 25 and the 23 will now add together. And so, voila, it's now in graphing form. And so now my h is negative 5, my k is negative 2, and I can go through and do whatever it is that I need to do. Let's look at another one. Now, for this example here, sometimes we have a value a, and the value a also disrupts us completing the square. So sometimes we're going to have to factor that out. So the first step is still the same. We're going to isolate c. So that plus 8, I don't want it, so I'm going to put parentheses around the rest. Then, sometimes if I have that a, we want to bring that to the front. We want to factor it out. So if I factor out 1/2 and bring that out, what's going to happen is this divides by 1/2, and so that turns into x squared. But when you divide negative 4 by 1/2, it turns into negative 8. Now, if you don't believe me, get out a calculator right now, do negative 4 divided by 0.5, which is the same as dividing by 1/2. And I bet you it'll say negative 8. So now that it's in this form, now I can complete the square. B over 2 squared. There's my b, negative 8. So I'm going to take the negative 8, which is my b, divide that by 2. I get negative 4, square it, and you're going to get 16. Now remember, I can't just add that 16 out of nowhere, so I have to both add and subtract it to make it balanced. This now factors. So a times c adds to b. Factors of 16 that add to 8 is negative 4 and negative 4. And so that's going to be x minus 4 and x minus 4, which is going to give me x minus 4 squared. So notice the 1/2 is still there. That turned into x minus 4. I still have the minus 16. And I still have the plus 8. Now, I just changed the parentheses into a bracket. It's just the same thing. It's just easier for us to kind of associate the two. That 1/2 now, I have to distribute to both of these. So the 1/2 times that, 1/2 times that. Now just leave the 1/2 in front. You don't multiply that through. Order of operations, I can't because of that. So you just leave that 1/2 in front. Combine like terms. And so there's my function. So I have a vertical shrink of 1/2, and I have a horizontal shift of 4. Let's do one more. So for example, on this one, we're going to isolate c. So I get x squared plus 6x minus 6. So we're going to isolate c. There's no a for me to factor out, right? There's nothing there. So now we're going to complete the square. 6 over 2 squared. So 6 over 2 is 3. 3 squared is 9. So I'm going to add 9 and subtract 9 inside the parentheses, and I'm going to leave that minus 6 on the outside. This will always factor. So a times c is 9. Factors of that add to 6 are 3 and 3. So that'll become x plus 3 squared, and I still have that minus 9 and then minus 6. That 1 distributes, so negative 9 and negative 6 give me minus 15. So now there's my h and there's my k, and I can graph this function much easier. So now we're going to take a look at a little shortcut. Now when my function is in this form, a x squared plus bx plus c, there's a special pattern that allows us to find the vertex really quick. And so if I use negative b over 2a, what that actually is going to do is it's going to give me my x value of the vertex. So this is going to give me my x value of my vertex. So I'll say x sub v. If you plug it back in, so that's what I did here, if you plug that back in, you're going to get the y value of the vertex. And so I did a little quick demo right here, where if I was to say, hey, find the vertex of this function. And so using negative b over 2a, negative, my b is 14, so negative 14 over 2 times a, my a is negative 1, negative 2, 7. So this is the x value of my vertex. Now if you plug that back in, so if I plug it back in, so you get negative 7 squared plus 14 times 7 minus 47. I just entered that in my calculator, and that gave me 2, so therefore my vertex is 7, 2. Now what's really cool about that is then I could say y equals, my a is negative, so negative x minus h squared plus k. So that's just another way for us to be able to construct creating our graphing form. But even though this is a shortcut, we need to know how to complete the square and be able to write it in that form, because when we get to conic sections, that ability is going to be very important. So what did we learn today? Well, we learned how to convert from a general form function to standard form in terms of quadratics. We also took a look at the quick shortcut to be able to find the vertex of a quadratic equation. And so what is the vertex of a standard form quadratic equation? We said negative b over 2a, and then if you plug it in, right? Or if it's in the, the graphing in standard form, so this is what we would use in general, we would say hk, because it's a times x minus h squared plus k. And so hk allows us to do that. This does conclude our lesson. If you have any other questions, please leave them in the comments.